Hello, and happy Friday. I was proud of you guys on your quizzes. Thank you for trying very hard. My goal is to make most of these math quizzes multiple attempt. Eventually, we'll have a test. Once we've covered all the different types of graphs, we'll probably have one big assignment, and that'll be a one-take thing. But we'll do a review for that. Um, I'm taking requests for what meme to put below me next. So we've covered linear, x, quadratic, x squared, cubic, x cubed, square root functions, the square root of x. We've only got a couple more main big boys. And the one we're going to cover today are absolute value functions. So these look like this. Y equals the absolute value of x minus h plus k. If you have not gotten this up till now is your chance to figure it out, because this is done the exact same way as our other ones. So the best way I can explain to you what this does is by graphing it. Let's take the world's simplest version of it. Well, first off, just a reminder as to what the heck absolute value does. The absolute value of -2 would be +2. That's literally it. It turns negative things positive. So, my example number 1, let's graph y equals the absolute value of x to see what it looks like. So, if I do my little t-table, we're going back to the standard 4 lines. What is my vertex going to be? Well, what's my h? I don't have one. And what's my k? I don't have one, which means it's going to be 0, 0. This is going to be normal. Go down 1, and then go down 2. Go up 1, and then go up 2. And now, what do I do with these? Well, let's plug them in. Y equals the absolute value of -2. What's the absolute value of -2? +2. Y equals the absolute value of -1. What's that? +1. Y equals the absolute value of 1. That's 1. Looks like 111. Y equals the absolute value of 2 is 2. So, what does this look like on a graph? Let's check it out. So, if I graph left 2, up 2, left 2, up 2, left 1, up 1, left 1, up 1, 0, 0, right 1, up 1, right 1, up 1, right 2, up 2, right 2, up 2. This creates a lovely V. Why? Why does this create a V? So something I'd like to show you guys is in a normal graph. Let's see, I can be clever with this. In a normal graph, this line would have done this, right? It would have gone straight up and down. Absolute value cannot be a negative. So my negative values for this are all going to be positive instead. So where it was going to be -1, now it's +1. Where it was going to be -2, now it's +2. So it's almost like in an absolute value function, you take the linear one and you break the bottom negative piece in half and you pull it up. It's like you're twisting it upward into a V shape. So let's do another example. I equals the absolute value of, let's do x minus 3. 1, 2, 3, 4. So what is my vertex going to be? Well, what's my h? -3. What do I do with h? Change the sign. So instead of -3, it's +3. And then what's my k? I don't see one out here, so let's say 0. Okay? So I'm going to go down 1 from 3. So 3 minus 1 is 2. 3 minus 2 is 1. 3 plus 1 is 4. 3 plus 2 is 5. Now let's plug my numbers in. Y equals the absolute value of x of 1 minus 3. What's 1 minus 3? Negative 2. What's the absolute value of negative 2? Positive 2. Y equals the absolute value of 2 minus 3. 2 minus 3 is negative 1. Absolute value of negative 1 is positive 1. 4. Y equals the absolute value of 4 minus 3. 4 minus 3 is 1. The absolute value of 1 is 1. Y equals 5 minus 3. 5 minus 3 is 2. The absolute value of 2 is 2. So I ended up with the same y's here that I did here. That's interesting. Okay. So when we put this sucker on a graph, right 1 up 2. Right 1 up 2. Right 2 up 1. Right 2 up 1. Right 3, don't go up. Right 4 up 1. 1, 2, 3, 4 up 1. Right 5 up 2. 1, 2, 3, 4, 5, 1, 2. I still get my lovely V shape, and it looks like this just got moved to the right, which makes sense because what is negative 3 supposed to mean? That is a horizontal shift right 3. Okay? Horizontal shift right 3, because you do the opposite of the negative 3. Let's do another example, and then we're going to do a small little review bit. So, let's do a really complicated one. Let's do y equals the let's do, I don't know, 1/4 of the absolute value of 8 minus x minus 3. Let's just make this as annoying as possible. Fantastic. 1, 2, 3, 4. So, first question is, what is my vertex? That's a bad idea. This is a bad idea. Because I haven't taught you about that. That's going to be bad. Let's do x minus 8. I'm not going to go into stuff I haven't taught you. So what would the vertex be? The opposite of h, keep k. So the opposite of negative 8 is positive 8. And that's the same, so negative 3. From here, I go down 2. So 8, 7, 6. 8, 7, 6. Up to 8, 9, 10. Alrighty. So let's plug it into this absolute monstrosity. Y equals 1/4 times the absolute value of 6 minus 8 minus 3. 6 minus 8 is negative 2. What's the absolute value of negative 2? Positive 2. So 1/4 times 2 minus 3. What's 1/4 times 2? 2/4, which is 1/2 minus 3. 1/2 minus 3 gives me negative 2.5. So negative 2.5. Now, I told you it can't be negative. This is fine. What can't be negative is an absolute value, is a negative inside the absolute. What can't be negative is this 2 when we take it out of the absolute value function. That's what can't be negative. Your y, that can be negative. Let's do 7. Y equals 1/4 times the quantity of 7 minus 8 minus 3. 7 minus 8 gives me negative 1. 1/4 times negative 1 gives me negative 1/4 minus 3. Negative 1/4 minus 3 would give me negative 2 and 3/4. Well, these are just terrible numbers, aren't they? I do it so you don't have to. Let's do the other way. Y equals 1/4 times 9 minus 8. Before I do this, I'm going to save you time by showing you a pattern. Look at these numbers. If you start going one direction, 0, 1, 2, you'll have the same numbers going the other way. 0, 1, 2. Look at this. 0, 1, 2, 0, 1, 2. That is the same for all absolute value problems. So if I have -3, -2 and 3/4, -2.5, I will have -3, -2 and 3/4, -2 and 1/2. So you only have to do 2 of them, and then you'll have the other 2. So please don't waste time. I'm not about that. So, on our big old graph, these are so close together that I'm going to leave myself a lot of room between the lines to see where I'm going. So, first point. Well, I kind of have to go out farther. 4, 5, 6, 7, 8, 9, 10. Okay. Over 6, down 2.5. 1, 2, 3, 4, 5, 6, down 2.5. So 1, 2.5. Over 7, down 2 and 3/4. 1, 2, 3, 4, 5, 6, 7. Down 2 and 3/4. So a little past 1/2. Right 8, down 3. 1, 2, 3, 4, 5, 6, 7, 8. Down 3. 1, 2, 3. Right 9, down 2 and 3/4 again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 2 and 3/4, so 2 and most of the way. And then right 10, down 2.5. Right 10, down 2.5. When I trace my lines, I should have a V. And guess what? I do have a V. What do you notice about this V? It is very stout. Why is it so stout? Because of that good old-fashioned 1/4 we got going there. Let's talk about our transformations here. This 1/4, right? If we had our equation, A equals x minus h minus k, or plus k. Your A talks about vertical stretches and vertical compressions. That was a very often missed question. So if it's less than 1, I've talked about this every lesson so far this week. If it's less than 1, then it's going to be a compression. It's a fraction, so that's less than 1. So here we have a vertical compression by a factor of 1/4. Here we have a shift, and what kind of shift? H for horizontal. We have a horizontal shift. Which direction? We do the opposite of H, so it's -8 would be left 8, but we do the opposite. So it would be right 8, because right is positive. This is -3 out here. This is K. K is vertical shift. We've done that since the linear problems. And it's -3, so it's down 3. That's what we've got. So, that's absolute value functions. I'm not going to drag it out any longer than that. Looks like today we have a short lesson, short video. Yay for the weekend! Let's talk about homework. So, I would like you guys to do the t-tables and the graphs for these problems. Problem number 1, I'm going to come up with these on the spot. Y equals 2 on the absolute value of x plus 2. Don't forget to tell me what your transformations are. The second one I want you to do is y equals the absolute value of x plus 3 plus 3. And the last one I want you to do is negative absolute value of x minus 1 minus 2. Don't be scared by this negative. Remember, if I said there's a negative on the outside, what does that do to the graph? If you don't remember, look at your notes. Don't let it scare you. That just means that whatever your answer is, it's going to have to be negative. So please do those 3 problems and list the transformations. Now, if you're good on transformations, the video is over for you. You are free to do your homework. If you don't understand transformations as well as you want, I'm going to be doing transformation review right now. So please stick around if you don't like transformations. So, transformations review. Again, this is not required notes. But if you don't like transformations, I would highly recommend you read this and take notes with me. So, talking about absolute value functions. Y equals a times the quantity of x minus h plus k. Let's talk about a. So a, let's show some examples. If a was either 2, 3.5, -7, if it's a number that's bigger than 1, then what it's going to do is it's going to stretch up, which means if you have this is the normal, if that's the original, stretch up would look like this. Do you see how much skinnier it is? That's what a vertical stretch would do. Now, if A was, let's say, 1/4, 7/8, 1/2, like the example I did earlier, that is going to squish down. So let's say the OG was that again. Then our vertically compressed graph would look like that. So that is what your different A values do to each other. I'm sorry, this is less than 1. So if it is a bigger number than 1, then it's going to stretch it up and make it skinnier. If it is a compressed function, it's going to squish it down and make it fatter. That's what your A value is doing. So when I ask you, is this a vertical compression or a stretch? If it's less than 1, it's a fraction. It's less than 1. If it's less than 1, that means it's going to be vertical compression no matter what. If that was the number 2, hint, hint, then that would be a stretch, a vertical stretch. Now let's talk about h. So h, or I'm going to say negative h, tells you it's a horizontal shift. And I'm going to give you a bunch of examples to explain to you which direction it'll be, because I think that'll show you better. If it is x minus 4, that means it's a horizontal shift right 4. If it is x plus 3, that means it is a horizontal shift left 3. So if it's negative in there, it's right. If it's positive in there, it's left. That's what you need to get it together. Now, if it's your k, that's your vertical shift. Now, for your vertical shift, if it's anything plus 5, that would be a vertical shift up 5. If it is anything minus 3, that is a vertical shift down 3. The key here, and this is the thing you got to remember. People missed this on the quiz because they didn't listen when I said it. If it is in the parentheses, it's h. If it is outside the parentheses, it is k. If it is inside the parentheses, it is horizontal no matter what. If it is outside the parentheses, it is vertical no matter what. Look at the A. Is the A in or outside the parentheses? It's outside, which means it's vertical. That's why it's a vertical stretch. If the K is outside, that means it's a vertical shift. The H is the only thing we have inside the parentheses. That means it's a horizontal shift. I hope this helps clarify a little bit. Um, and I've now broken 20 minutes. I was hoping to keep this in the teens, but best of luck on your homework. Please ask me if you need any help. The odds are we're going to have a quiz on Tuesday on absolute value functions and whichever one else I decide to do next. Probably going to be rational functions, which is fractions. But with that being said, I hope you have an absolutely splendiferous weekend. Again, homework is due Sunday night, but I'd recommend doing it sooner rather than later. Goodbye.